In this video, we're going to do some practice problems relating to hyperbolic functions. So first, let's show the Pythagorean-like identity, cosh squared minus sinh squared equals 1. This is something that we could have done when doing the derivative of tanh earlier in the last video. So first, let's talk about cosh squared. We're going to write that as e to the x plus e to the negative x over 2 quantity squared. And then sinh squared is going to be e to the x minus e to the negative x over 2 squared. We're going to show this is equal to 1. So first, let's deal with just taking all of these 1/2s out. We can write this as e to the x plus e to the negative x times e to the x plus e to the negative x all over 4, and subtract off e to the x minus e to the negative x, e to the x minus e to the negative x over 4. Now we're going to do a bunch of foiling. I guess we'll take care of the 4 in a little bit. Let's do a bunch of foiling now. So the first is going to be e to the x times e to the x. That is e to the 2x plus e to the x e to the negative x. Let's just do some work up here. So remember, e to the x times e to the x is e to the x squared, and that's the same thing as e to the 2x. E to the x times e to the negative x. You can add the exponents. That'll give you e to the 0, which is 1. So we'll write it out this time, and then know that's going to be equal to 1. We have the same term here, and then plus e to the negative 2x all over 4. Then we have, on the other side, e to the 2x minus e to the negative x, e to the x, minus e to the x, e to the negative x, plus e to the negative 2x, all over 4. So we said that all these intermediate terms are going to be equal to 1. They're e to the 0. So we're going to have here, bringing it all together, e to the 2x plus 2 plus e to the negative 2x minus e to the positive 2x plus 1 minus e to the negative 2x. This should be a positive here. So remember, what we're doing here is we are distributing this negative to each term. We get a minus, oops, sorry, I had that right before. We have a minus e to the 2x minus negative 1 twice, and then a minus positive e to the negative 2x, all over 4. And we can see the e to the 2x's cancel out, the e to the negative 2x's cancel out, and we are left with 4 over 4, which is 1. So this identity is just built from those exponential functions. All right, let's do a limit with these functions. And again, you don't need to know anything about the sinh and cosh specifically, except for the definitions in order to do this. So what we need to do is rewrite sinh and cosh in terms of their definitions. And with the insides being 2x and 3x, we're just going to replace the x with those values. So we're going to have sinh first is going to be e to the 2x minus e to the negative 2x over 2, and cosh will be e to the 3x plus e to the negative 3x over 2. So when we kind of put this into one big fraction here, the 2's will cancel out, and we'll be left with e to the 2x minus e to the negative 2x all over e to the 3x plus e to the negative 3x. The 2's cancel out in that limit. So now we think about what happens with the limit as x goes to infinity. And it might be best to think about breaking this up into 4 different limits. We have the limit of e to the 2x minus the limit of e to the negative 2x all over the limit e to the 3x plus the limit e to the negative 3x. And it's important to note that the e to the negative 2x and e to the negative 3x both go to 0 because you're going to have e to the negative infinity when you kind of plug that in. Or you can think about that the limit as x goes to infinity of e to the negative x is the same as 1 over e to the x, and that is 0. So overall, this turns into just the limit of e to the 2x over e to the 3x. And we can write that as just the limit of 1 over e to the x. We can cancel out those exponents like that. You can think about this as equal to e to the 2x minus 3x. That's e to the negative x. And overall, this is going to be equal to 0. So one more practice problem, or 2 more. Let's do some derivatives with these hyperbolic functions. So the first is cosh squared of x squared. Note this is function composition, so we're going to need the chain rule. It's important to note that the chain rule is because we have cosh of x squared, all of that squared. The inside function is cosh of x squared. The outside function is something squared. So the derivative should be the derivative of something squared, which is 2 times the something. We leave the inside alone. And we multiply by the derivative of the inside. So all of that work was just to deal with the squared term. Now we have to do chain rule again. This time the inside function is x squared. The outside function is cosh. So we're going to, first of all, copy down what we had before, 2 cosh of x squared. We're going to take the derivative of the outside, which is going to be sinh of, leave the inside alone, and then multiply by the derivative of the inside function. And we get 2 cosh of x squared sinh of x squared times the derivative of x squared, which is 2x. We'll do one more problem, that being the derivative of tanh of 5x plus x cubed. Note we need the chain rule here because we have function composition. The inside function is 5x plus x cubed. The outside function is tanh. So first we take the derivative of the outside function, which is 1 over cosh squared of something. We leave the inside alone, and we multiply by the derivative of the inside. And then we can write this as 1 over cosh squared (5x plus x cubed) times the derivative of 5x plus x cubed, which is 5 plus 3x squared. And there is our derivative. So other than derivative rules, it's nice to just use the sinh and cosh rules. Other than that, go back to the definition anytime you have to deal with a problem dealing with these functions.